Okay, so here's a bit of a demon 64. It's actually a 64 in a VIC20 case. It's been kind of butchered. Keyboard doesn't look too bad, but the case itself is pretty brown. Good thing about this, though, the strange thing about this is it's actually got, obviously there's a built-in reset button there, also got some alternative kernels in it. It doesn't power up, unfortunately, so I can't show you that yet, but we'll have a look and find out in a bit. But you've got the C64 kernel, you've got the Brian Quick kernel. I don't know if there's anything under there, I haven't pulled that one out yet, but as you can see there's a cable that comes here, runs all the way down and sits in where the normal kernel would normally sit. PLA is mashed up, so that leads me to believe that, and as is the VIC, you've got some heatsink on there. There's a little bit of leakage there, which isn't going to stop it from powering up, but I'll swap that bad boy out because that's not going to be right. It's going to lead to possibly a little bit of hum on the 12 volts. But this is a slightly later 64 board as opposed to an earlier one. It would have had a metal, originally would have had a metal case across the top, because the PLA and the VIC, as you can see, are heat sunk, or I've got heatsink paste on, and that means the fins from the metal case used to sort of apply to the top of there and take some of the heat away. It's unusual that the 6581 or the SID isn't heat sunk or hasn't got any trace of squidge on it. It might have a little bit there, because that's normally heat sunk as well. So this won't power up. Everything appears to be active, everything appears to be okay. You can see I've got my scope clips on there. What I've done is I've removed the top bit. I've removed the top bit, and therefore there's no kernel sat in there. That's not a big problem because this is a dead test cartridge, and the dead test cart uses the Ultimax mode, which bypasses the kernel on the 64 anyway. So the only thing that really needs to be functioning is this, which is the PLA. That needs to be awake, the processor needs to be awake, you've got to have volts and everything in the right places. Okay, so I've now removed the CIAs, we've removed the character, the basic and the kernel ROMs. I've also taken the SID out, and literally this is all you need in order to get the dead test to go, so you can remove and isolate all of those components straight away. This is the read-write line on the RAM. Okay, now with the dead test cart, that normally flashes away a bit more than that, so you can see that it's actually trying to start. Oh, we've got another little try there. So no, that's what my scope doing. There we go, it's got some more going on there. Now, I haven't thought about it. It does look like it's actually, the dead test cartridge is actually powering up. So what I wanted to do was make sure that the VIC was being selected and kicked in. Now, the VIC the VIC chip select is on pin 10. As you can see, that stays high. Now, that would be the case. I'd expect that if it wasn't powering up, if the system wasn't powering up. But the read-write on the RAM appears to be working correctly. That seems to be okay. So that there actually means that the RAM is being read and written to. So that's why we're getting the it's active low. Write is active low, which is right. As I said, the data lines are fairly active as well. That's not what I'd expect to see if the machine was hanging. So it's either going to be the PLA or logic. We've got some horrible MOS logic here. U15 and U27, horrible MOS logic, notorious for failing. 257s are okay, but the VIC's chip select, I believe, comes from the PLA, is ANDed with a couple of addresses, 14 and 15, I believe, I could be wrong, and then that ends up going out to the VIC. So I'm just going to check the circuit diagram. So looking at the circuit diagram, you've got here I/O on pin 1 of this 74LS139. An 810 and 11. Now the I/O comes from the PLA. You'll notice that comes from over here. There's the PLA U17. And I/O, I believe, is the enable for this 74LS139. I'm not entirely sure what that is. I think it's a multiplexer of some sort. However, depending when the I/O kicks in on what's on address 10 and 11, what's on those two lines at that particular time, depends on whether it kicks in the CIAs, the colour, the VIC, or the SID. So off of pin 4, you see the VIC, pin 10, chip select, which is active low. That's not working, so we're going to have a look at what's going on, see if there's any I/O or see if there's any activity on pin 1. If not, it's going to be the PLA which is the issue. So we'll have a look and see if that ever gets kicked in. If it isn't, we can change the PLA. If not, it's that U15 is one of those horrible MOS chips which we can change, we'll swap that over and see how we get on. Right, so this could be a lesson in going too technical. What I've actually done is just, you can see I've scrubbed the I've scrubbed the heatsink stuff away from that, and in doing so I've actually pushed the PLA back in, I think back into its socket, or reseated it. It didn't go clip when I pushed it. However, if I now switch the system on using the dead test cart, black screen to death, we'll get the black screen, which is perfectly normal. The dead test cart stays black while it's doing its RAM test, and will flash the screen if there's any issues. And there we go. So it was actually working in the background, and then we got your 0 page and your stack page, which will come up okay. We'll test the RAM in a second. So it was working okay, but a dodgy connection on the PLA was obviously causing us a problem. So now that's working and we've got the system powering up, I'm going to put the main chips back in and put that curious kernel back in and see what we get. So it looks like all's groovy. However, after about 60 seconds of working, the C64 did this. Now that screen is indicative of a PLA failure, and the reason that is because the VIC chip is displaying whatever data or whatever happens to be on the bus at that particular time, because the PLA isn't selecting it at the right time. So it's displaying absolute rubbish because it doesn't know what it should be looking at. The data is wrong, the addressing is wrong, so the PLA is just selecting it when other things might be looking at the bus. So that's why you get this random stuff. So it does actually point, as opposed to me or the socket being dodgy, it does actually point to a defective PLA. So you can't buy new PLAs, but I do use a PLS 100N, which was the original chip that Commodore used to use before they started. What they did was actually delid the PLS 100, so take the lid off it, have a look at it. Started manufacturing the 906114-01 instead of buying the chips in from Signetics as it was at the time. It was much cheaper for Commodore to make them. However, they were notoriously unreliable as they ran very, very hot. So here I am a few days later. I've taken the board out of the case. I've also removed the separate kernels from the system. I've plugged it in. As you can see, we've replaced the PLA. I've heat sunk the CPU and the SID. I've also heat sunk the VIC just to make sure they're nice and kept nice and cool as possible. And I've replaced that cap as well. So we were looking at the PLA being the issue. We've still got a horrible MOS logic in there, but the PLA definitely has turned out to be the issue. There's no faulty RAM or anything. So this has got Brian's DOS on it. So when we now switch it on, we get Brian's DOS. Or we can swap the switch across here and move up. And then we get the standard Commodore screen, so we've got the standard kernel as well. So yeah, basically a lot of faffing around, a lot of messing around and experimentation, bits and pieces by me, but it turned out to be this little monkey, the PLA, all along. Now these are the PLS 100Ns I was talking about. They specially programmed. I managed to get hold of some of these. They're not easy to find, especially blank, but they're a chip that can be programmed, and it acts as a PLA. And as I said, it was the original unit that Commodore used to use. These particular ones, this was manufactured in 1999. They run a lot cooler than the PLAs, as I said, so you don't need to put heatsink on those. So yeah, all in all, nice, easy fix. I hope you've enjoyed having a little look and coming with me along my journey, whether I make things a lot more complicated than I need to be. And yeah, hope you've had a good time. Thanks for watching. Cheers.